Okay, in the previous question, we managed to find the eigenvalues and eigenvectors of a 2 by 2 matrix. Now, I'm going to teach you how to find the eigenvalues and eigenvectors of a 3 by 3 matrix. Okay, we know that the characteristic determinant is equal to 0. Okay, 2 subtract lambda, negative 1, 1, negative 1, 2 subtract lambda, negative 1, 1, negative 1, 2 subtract lambda. Okay, the determinant of this is equal to 0. This reduces to lambda cubed minus s1 lambda squared plus s2 lambda minus s3 is equal to 0, where s1 is the sum of elements in the principal diagonal. So the sum of elements in the main diagonal is 2 plus 2 plus 2, 2 plus 2 plus 2. This is equal to 6. S2 is the sum of minors of elements in the main diagonal. Okay, this is an element in the main diagonal, 2 is an element, again this 2 is an element in the main diagonal. So the minor of this 2 is nothing but 2, negative 1, negative 1, 2. You take elements which does not belong to the row and column where this 2 is being found. Okay, if you check 2 is here, you are not going to take these elements. You are not supposed to take this element. You take this element plus now 2, 1, 1, 2, 2, 1, 1, 2 plus 2, negative 1, negative 1, 2, 2, negative 1, negative 1, 2. 4 subtracting 1 plus 4 subtracting 1 plus 4 subtracting 1. This is 3 plus 3 plus 3, which is equal to 9. So S2 is equal to 9. S3 is nothing but the determinant of matrix A. Use your calculator to find the determinant of matrix A. The determinant of matrix A is 8. Okay, let me check. 2, negative 1, 1, negative 1, 2, negative 1, 1, negative 1, 2. So, okay, sorry. The determinant of this matrix is 4. Okay, the determinant of this matrix is 4. Now, this equation becomes lambda 3 minus S1 is 6 lambda squared plus S2 is 9 lambda, okay, minus 4 is equal to 0. If you solve this equation, you are going to find the eigenvalues. In this case, if you solve, the eigenvalues are 4, 1, 1. Okay, so the eigenvalues are 4, 1, 1. You are supposed to know that it is not possible to find the eigenvectors without finding the eigenvalues first. So you are supposed to find the eigenvalues first. After finding the eigenvalues, you go on to find the vectors. The characteristic equation is given by a minus lambda I into x is equal to 0. Okay, this is 2 minus lambda minus 1, 1 minus 1, 2 minus lambda minus 1, 1 minus 1, 2 minus lambda, this into x1, x2, x3 is equal to 0. This becomes 2 minus lambda into x1 minus x2 plus x3 is equal to 0. This one, this one, this one. This becomes minus x1 plus 2 minus lambda into x2 minus x3 is equal to 0. This becomes x1 minus x2 plus 2 minus lambda into x3 is equal to 0. This is equation 1. Okay. Case number 1. If lambda is equal to 4, the equations 1 become okay, this is negative 2 x1 negative x2 plus x3 is equal to 0, negative x1 x2 x3 is equal to 0. This is x1 minus x2 minus 2x3 is equal to 0. This equation can be reduced to 2. If you factor out negative, this becomes x1 plus 2x2 plus x3 is equal to 0. If you don't like to factor out negative, no problem. But if you want to factor out, you can factor out. If you check, these three equations are different. Since they are different, you are supposed to choose two equations. I am going to choose this equation and this equation. Okay. Now, x1, x2, and x3. The coefficient of x1 in this equation is negative 2. The coefficient of x2 in this equation is negative 1. The coefficient of x3 is 1. The coefficient of x1 is negative 1. The coefficient of x2 is negative 2. The coefficient of x3 is negative 10. Okay, sorry. Remember, I reduced this equation into this. So the coefficient of x1 is 1. The coefficient of x2 is 2. The coefficient of x3 is 1. Okay. Now you write x1 by is equal to x2 by, which is equal to x3 by. Okay, x1, you're not supposed to take other elements in the same column with x1, so you take negative 1, 1, 2, 1. Negative 1, 1, 2, 1. x2, you're not supposed to take elements in this column, so you take 1, 1, negative 2, 1, 1, 1, negative 2, 1. Why I didn't write negative 2, 1, 1, 1? Make sure this column should be the same. Okay, this column should be equal to this column. This is 1, 1, this is 1, 1. Now x3, you take negative 2, 1, negative 1, 2. Okay, if you check, this is x1 by, this is x2 by, this is x3 by. Okay, let's find out. This is negative 1 subtract 2 negative 3. x1 by negative 3 is equal to x2 by, this is 1 subtracting 2. This becomes 5. This is negative 4. subtract 1, this is negative 3. If you factor out negative 1, okay, it becomes x1 by, okay, we are going to factor out negative 3. This becomes x1 by 1 is equal to x2 by negative 1 is equal to x3 by 1. Okay, this simply means that the eigenvector corresponding to the eigenvalue for x1 is equal to 1 minus 1, 1. This is the eigenvector corresponding to 4. Okay, case number 2. Case number 2. If lambda is equal to 1, the equation, this one, reduces to or becomes, okay, now lambda is equal to 1, this becomes x1 minus x2 plus x3 is equal to 0. This is negative x1 plus x2 minus x3 is equal to 0. This is x1, subtract x2 plus x3 is equal to 0. If you factor out negative 1 in this equation, this becomes x1 subtract x2 plus x3, which is equal to 0. If you check, you have only one equation repeating itself. I said that if the equation is repeating itself, you take one equation. So I'm going to take x1 minus x2 plus x3. Okay, is equal to 0. Then you assign any value to one of the variables. So I am going to assign 0 to x1. So let x1 be equal to 0. This becomes minus x2 plus x3 is equal to 0. This is negative x2 is equal to negative x2. If you divide both sides by negative, this is x2 is equal to x3. Okay, so the eigenvector corresponding to this eigenvalue is equal to, remember, x1 is equal to 0, x2 is 1, x3 is 1. Okay. x2 is equal to 0, 1, 1. Now we want to find the third eigenvector. Case number 3. In case number 3, it's the same. If lambda is equal to 1, so I'm going to add an I. Case number 3, if lambda is equal to 1, the equation I becomes this. Okay, I'm going to take one equation again, but now in case number 2, I said that I'm going to assign the value 0 to x1. Now I'm going to assign the value 0 to x2. Let x2 be equal to 0. This becomes x1 plus x3 is equal to 0. x1 is equal to negative x3. Okay, this is x1 by negative 1 is equal to x3 by 1. Okay, if you do cross multiplication, you will return here. Okay, why am I doing this? It's something like the purpose is to find x1, the aim is to find x3, not to find negative x3 or x1 or something, the relation. So to make it easy, that's why I'm doing this. Okay, so that you can understand. I think this is okay. Okay, now x3 is equal to x1 is negative 1, x2 is 0, and this is 1. Okay, so the third eigen vector corresponding to 1 again is negative 1, 0, 1. Okay, job done.